In this video, we will look at solving systems by substitution. By the end of this lesson, you should be able to solve a system of linear equations in two variables algebraically using the substitution method. This is our second of three methods we are going to look at for solving systems. In our last lesson, we looked at solving by graphing. So we're going to look at that again and compare it to solving by substitution, our second method of solving. So we want to find the solution. Remember, our solution is an ordered pair to the system of equations. So we have our first equation, y equals 3x minus 1. My slope is 3 over 1, and my y-intercept is negative 1. So I'm going to graph my y-intercept, negative 1, go up 3, 1, 2, 3, over 1, 1, 2, 3, over 1. Go back to my starting point, down 3, over 1. Once I have my line, I'm going to connect my points. And I have my first line graphed. For my second line, I have x plus y equals 3. Here I can't solve it until it's solved for y, so I'm going to subtract x from both sides. So I have y equals negative x plus 3. Again, I'm going to identify my slope, which is negative 1 over 1, and my y-intercept, which is 3. When I graph that, I start at 3, and I go down 1, over 1, down 1, to the right 1, go back up and fill in the rest of my points, connect, I'm going to connect my dots to form my line, and I notice my intersection point right here is that I go to the right 1 and up 2. So my solution is the point 1, 2. This is how we looked at solving systems in our last lesson. Today we're going to look at substitution. So this is another method we can use when we don't want a graph or we don't have a graph available. So we have our steps up here. Step 1, isolate one variable in one equation. So I want to have one variable by itself, and it looks like I already have that. My first equation says y equals 3x minus 1. So I already have it solved for y. So I do not need to solve my other equation for y. I can leave this in its original form. But what I am going to do is I'm going to plug this expression into the other equation. So I'm going to take this expression right here, 3x minus 1, and substitute it or replace it in for y. So now I have x plus, instead of this y, I'm going to put my 3x minus 1 equals 3. Now I'm going to, I would distribute if I needed to, but I don't need to here. I'm going to get rid of my parentheses. Combine like terms, x plus 3x is 4x, minus 1 is equal to 3. Add 1 to both sides. 4x is equal to 4. X is equal to 1. So I solved my one variable equation, and now I'm going to take x equals 1 and put it back in to my other equation. Use this value to solve for the other value. I have my x coordinate, now I need my y. So I'm going to write y equals 3. Instead of my 3, I'm going to put my x that I just found, subtract 1. So y is equal to 3 times 1 is 3, minus 1, y is equal to 2. So I have here the point 1, 2. If we notice, it's the same answer I got when I graphed. Let's take a look at our next example. In this one, we are just going to solve each linear system by substitution. So here, My first step says to isolate one variable in one equation. Well, that's already done for me. This says x equals 3y minus 4. When it says x equals, I'm going to replace that variable. So I'm going to replace the x in my next equation. So I'm going to write 2. Instead of x, I'm going to write 3y minus 4 plus 3y equals 19. I am going to distribute my 2 to both terms. 6y minus 8 plus 3y equals 19. I'm going to combine like terms. 6y plus 3y is 9y minus 8 equals 19. I'm going to add 8 to both sides. 9y is equal to 27. Y is equal to 3. Now again, once I have my y coordinate, once I have one of my numbers, I need to find the other one, because remember, we're looking for an ordered pair. I'm always going to come back up here, and I'm going to write x equals 3. Instead of my y, I'm going to put the number 3, because that's what I got here. Substitute that in. X is equal to 3 times 3 is 9 minus 4. X is equal to 5. So my coordinate that I'm looking at is the point 5, 3. I want to have my x and my y. That is my solution. We can see here our last step is to check our solution. Let's go ahead and check real quick, just like we did in our last lesson. We're going to check to see if this point works for both of these. Let's go ahead and try that. So I have my x equals, so 5 equals 3 times my y, which is 3, minus 4. So I get 5 equals 9 minus 4. Well, that one works. Let me check my second one. For my second one, I have 2. My x is 5 plus 3 times my y coordinate, which is 3, equals 19. 2 times 5 is 10, plus 3 times 3 is 9, is equal to 19. 19 is equal to 19, and that works. So it is a solution. When I checked, I got the correct answer. Let's take a look at one more example. And in this one, it looks a little bit different because both of my equations are solved for y. So I have y equals 5x plus 3 and y equals 2x minus 9. This doesn't make it any different. It just doesn't matter which one you substitute. So I'm going to take 5x plus 3. This is as y equals. I'm going to replace y. So I'm going to write 5x plus 3 is equal to 2x minus 9. I'm going to solve for x. So I have 3x plus 3 is equal to negative 9. Subtract 3 from both sides. 3x is equal to negative 12. That makes x is equal to negative 4. And once I have my x value, remember I can go and plug it in. So I'm going to do y equals 5 times negative 4 plus 3. So y is equal to negative 20 plus 3. Y is equal to negative 17. So when I write my coordinate, I always write x and then y. My solution is negative 4, negative 17. This is the end of our video. Please make sure you bring your notes to class and we'll continue to work on some examples.